So we're now going to continue with our coverage of Java structured concurrency. If you recall, what we talked about last time was the executor service variant of structured concurrency, which is very simple, maybe a little too simple, where whenever you submit a task, it actually creates a Java virtual thread to run the task. So that's what we did last time. And I talked about some of the limitations, and I said that something else would address those limitations, and that something else is Java StructuredTaskScope. So it's another model of Java structured concurrency, and it's really the one that's getting the bulk of the attention right now. So Java TaskScope is the basic API for Java structured concurrency that's popular today, or very, very recently in the last couple of months. And what it does is it splits a task into several subtasks that run concurrently within a syntax block. That actually sounds very similar to what we did with the executor service stuff we looked at, but this has some other bells and whistles that makes it cooler and more flexible and generalizable. There are several nested subclasses defined within StructuredTaskScope. And what's kind of funky about these subclasses is they're nested subclasses. They're nested classes that inherit from StructuredTaskScope. So it's kind of a weird thing where you've got a nested class that itself is a subclass of the parent class. And we'll take a look and see how that works. One nested subclass is called ShutdownOnFailure. And this is going to be used for what's often referred to as kind of invoke all style processing. And what it does is it'll be used to run a bunch of subtasks concurrently. And the idea is, ideally, they all finish and we get all the results back and we can do something with all the results. So it's kind of invoke all. You want everything invoked. However, if something goes wrong, if one of the subtasks fails, then the whole thing shuts down. And everybody who's still running gets canceled. So that's what this does. So it shuts down on failure. So when something fails, all the subtasks shut down. The second model, which is kind of a variant of this, is called ShutdownOnSuccess. And what this says is it says, send a bunch of things off, and this is what's called the Invoke Any model. And whichever one successfully completes first, take its result and cancel everybody else. So those are the two models. And these are very, very common models when you're dealing with concurrent processing. You want all the results to come back, or you want the first result to come back. So shutdown on failure, all the results come back unless something fails, in which case they're canceled. Shutdown on success, whichever one finishes first, we take that result. The other results are not relevant, and so they're canceled. So you can think of shutdown on success as being like invoke any. And the example here, there's a method called Invoke Any that's part of the Java executor service, similar kind of idea. I was trying to think of good examples of Invoke Any, and a good one would be Jeopardy, where whoever gets the first right answer wins the round, and the other answers don't count. It doesn't matter what you're going to say. So there's other examples too, but that's a nice, easy one. So how do you program with shutdown on failure? So I'm going to give you a high-level view, and then we're going to dig down and walk through some examples in more detail. Shutdown on failure is used with the try with resources feature, just like the executor's thread per task executor stuff that we looked at earlier. And so what we do is, you can see we use the scope. So we say try var scope new StructuredTaskScope.ShutdownOnFailure. Little verbose. We could actually go ahead and import this outer class and just say new shutdown on failure, but I'm trying to be more comprehensive. Then what we're going to do in this particular example is we're going to go ahead and find the user and fetch the order. So we're going to go look up the user. Let's say this is a database operation like Amazon kind of thing. We're going to go ahead and fork off two requests that are going to run in parallel. One's going to go and authenticate the user. Second's going to go and find some order that we have. We have an order ID and a user ID. We fork off virtual threads. They both go run in parallel. And this is more flexible, as you'll see, than the executor's thread per task executor, because it's got a join method. Remember, with the executor's thread per task executor, you had to wait till you hit the close curly brace for things to finish. Well, here we can be a little bit more granular, more fine-grained, and we can say scope.join. And what this says is, it says wait for all the threads to finish, or for the task to shut down if an exception should occur. So let's be optimistic, let's say both these things finish without failure. Join will simply wait, doesn't block, it just waits. It actually pitches in and does processing. It'll wait for the processing to finish. And at that point, either we've succeeded and we've got a result, or if something happened and one of these guys threw an exception, we can rethrow that exception if we need to. So if a subtask completed abnormally, boom, we're going to throw a failed. Notice that if subtask finished abnormally, join wouldn't wait for all the other subtasks to be done. It would just return prematurely, and we would throw the exception. And now we've got, at this point, we've joined. Let's say everything went well. We've got the results. And now what we're going to do is we're going to make a new response to the request where we're going to say, take the results from the user, take the result from the order, and make a new response and send that back. And notice that we're using a new method that was defined in recent versions of Java called result now. So I want answers. I want them now. I deserve the truth. I deserve the answers. If you ever see Tom Cruise in A Few Good Men, you know what I'm referring to. So we get the result now. We're not going to block. We're not going to wait. We're just going to get the results. And we should have the results because we wouldn't have gotten this far if things didn't go successfully, because otherwise we would have bailed out here. So that's a very simple example of using shutdown on failure and try with resources. Let's take a look at another programming model. This is the Java StructuredTaskScope. So this also uses try with resources, just like before, except this time we create a StructuredTaskScope variable. And we also have to tell it what type the return value of this is going to be. So it's going to be a list of big fractions. And we'll take a look at this example in more detail later. But really quickly, what we're going to do here is we're going to go ahead and quick sort the list that we've got here. So let's say we've got a list. We're going to quick sort it. We're going to heap sort it. We're going to do those two things in parallel. So we're going to fork off virtual threads. And whichever one finishes first, heap sort or quick sort, we're going to take that result. So we start things off, and we're going to return the result, which would be whichever one finished first. So we run these things in parallel. We wait for the first result to complete, whichever one comes back first. So the join call will short circuit in the sense that once we get a result of either one, the other one will be canceled. We have one result, and then we return the result there. So the first result that was done, we're going to give that back. So that's the other common use case, shutdown on success. And you'll see some interesting examples of this later. So that's the end of our overview of how to program with Java Structured Scope. We're going to look at some case studies that'll go in much more detail, but that's a good starting point to see the core classes that are involved.